This presentation is Module 4 of Chem for Bio at Northern Virginia Community College Annandale campus. And this module is all about energy. You may wonder why you have to know anything about energy if what you want to study is biology. Well, biological functions, biological processes always involve different forms of energy, conversion of energy between the different forms, and transfer of energy from one substance to another. So you cannot study biology without studying and having a basic appreciation of the different forms of energy. When asked about energy, most people simply think of power sources, some of them natural, some of them man-made. Fire from a charcoal grill, the energy, the electrical energy stored in a couple of AA batteries, solar power, the gasoline used to power your car, or the electricity used to power your car, the nuclear power plants that provide electrical energy to heat our homes and run our devices, the hydroelectric power that is used to heat our homes, cool our homes, and power our devices, as well as renewable sources such as wind and, as I mentioned previously, solar. So people often think of man-made sources of energy and particularly electricity. But there are many different forms of energy that exist naturally all around us. Some of them are quite dramatic, quite violent, and some of them are quite subtle. The growth of a plant from a seed is a demonstration of a natural energy change. The capturing and consuming of dinner is an example of a natural energy change. Even just the flexing of your foot is an example of a subtle natural energy change. There are two main types or forms of energy: potential energy and kinetic energy. Potential energy is usually described as stored energy. It is the energy due to structure or to location, whereas kinetic energy is the energy of motion. In studying biology, there are four important sub-descriptions of potential energy: the energy levels of electrons, nuclear energy, chemical energy, and gravitational energy. The energy level of electrons was described in an earlier module. The energy of the electrons that surround the nucleus in an atom vary based on the location. Electrons that are closer to the nucleus are more strongly attracted to the positive charge in the nucleus and hence are more stable or lower in energy. So the energy of an electron increases with each increasing shell. Consequently, it's the electrons in the valence shell, that outermost electron shell, that are the highest energy electrons, and that is why they are the electrons that engage in chemical bonding. Nuclear energy is another form of subatomic energy. It is the energy stored in the atomic nucleus. It can be released by two general processes, either fusion, which is the joining of multiple atoms' nuclei, or of fission, splitting up an atom's nucleus. Again, in a previous module, we described the radioactive decay of unstable isotopes. That is a type of nuclear energy that is released when that atom decays. Chemical chemical energy is the energy stored in the bonds of a compound. This energy is transferred, is converted, and changes as chemical bonds are broken and formed. Generally speaking, energy must be absorbed for a bond to be broken, and energy is given off when a bond is formed. But the process, because it usually involves the breaking and forming of so many chemical bonds, is a rather complex issue. But the energy stored in the food you eat on a daily basis is the chemical energy stored in the chemical bonds of the carbohydrates, the fats, the proteins that you have consumed. Your body uses this chemical energy. It breaks the bonds, then it forms other compounds, for example, which also get used. For example, your body uses ATP. It takes the complex ATP molecule, breaks it into simpler molecules, and in the process, energy is released. The last type of potential energy is simply gravitational energy. Gravitational energy is related to the location of an object with respect to the surface of the Earth. The farther an object moves away from the Earth, the more potential energy it has due to that gravitational pull. The four important types of kinetic energy are the simple energy of motion, radiant energy, thermal energy, and electrical energy. Energy of motion is exactly that. A moving object has kinetic energy. When you walk, when you run, when you bike. Radiant or light energy is also a form of kinetic energy. Light energy is better described as electromagnetic radiation. It is not just visible light. Visible light is a tiny fraction of the electromagnetic spectrum. Electromagnetic or light energy includes everything from radio waves to microwaves to ultraviolet rays to X-rays and gamma rays. Thermal energy is better known as heat energy. It is simply the energy due to the random motion of atoms and molecules. So the faster the atoms and molecules are moving, the greater the heat energy that is created. Heat energy the transfer of heat energy is very straightforward to measure because heat energy is always transferred from a warmer object to a cooler object until both objects are at the same temperature. Consequently, we can measure the transfer of heat energy by using a simple thermometer. The last form of kinetic energy is electrical energy. Again, it's the energy of movement, but this time it's the energy of electrical charges, or the movement of electrical charges. Electricity is simply the movement of electrons along a wire.